Sectors like vehicle production and aerospace are in the midst of profound changes in product markets, in manufacturing methods, and in supply chain organisation. These are all evident on a global scale. In this programme, we focus on one sector, automotive component manufacture. We look at methods of reorganising production processes that provide an essential response to intense competitive pressures that affect all manufacturers.
In the world automotive market today, there's an overcapacity of many millions of units, and the effect of that is that the customer has a greater and greater choice of product type, product capability, product cost, and of course perceived product value.
Current practice in the car industry has been strongly influenced by manufacturing methods in leading Japanese car makers, methods which underpin long-term, consistent success. These methods contribute to outstanding performance in three critical areas: quality and delivery, where meeting stringent customer requirements has become mandatory, and progressive reductions in component costs.
Cost is now the driver worldwide. Parts can be made almost anywhere in the world. We had to make sure that our costs come down, and in nearly every case with our customers, we're on a year-on-year cost out. So quality, absolutely number one and second nature. Delivery has to keep on improving, and the conditions for delivery have to improve, the volumes, the quantities, the day-by-day deliveries, and cost has to come down and will have to continue to come down year on year.
Manufacturers face a seemingly impossible challenge. This is to meet high-quality standards with zero defects and tight delivery schedules, whilst continuously reducing costs. The most efficient methods are essential for survival today.
There is a recognition that with good, focused industrial engineering practice, you can still make significant inroads into reducing costs. It's a principle that was indoctrinated in the Japanese motor industry for years and has led to the success of that industry. And as a recognition amongst certainly UK suppliers that we needed to get involved in these type of programs to remain viable.
Many of our competitors at the same customer have actually, just when we've managed to get cost out and therefore have been able to offer the cost downs, have come along to say, well, we'll reduce our price too. But there, of course, they're reducing their profit levels as well. That means eventually they're not going to be able to compete at all. They're certainly not going to be able to make the investment that's going to be necessary to sustain them long term.
It's becoming a way of life that just taking cost out of your products and delivering ongoing performance improvements, not only in terms of cost, but taking cost out of logistics and delivery and all of those other things that add cost into a process, is a given, is a way of life. And if we want to stay in the game, that's what we have to be doing, all of us.
Cost down is now a continuous requirement as a condition of doing business. Suppliers have to respond to this by making continuous improvements in methods and in efficiencies, not least to protect the profits needed for future investment. For example, Company A and Company B meet customer price requirements where total costs plus profit equals price. As cost down impacts on both companies, Company A reduces costs and maintains its profits. Company B does not attack its cost levels, so it has to reduce profits. This cannot be sustained if the company is to stay in business, hence continuous improvement. We've referred to the importance of QCD, quality, cost and delivery. But there is a fourth factor: partnership. Companies are involved in partnerships with the companies they supply to and companies they buy from. The critical challenge is whether these partnerships are characterised by continuing suspicions and hostilities from the past, or whether they are positive partnerships that strengthen competitiveness throughout the supply chain.
There's a need to recognise that there must be synergy throughout the supply chain. that there is no benefit in one portion of the supply chain having a flexibility and lead time capability that far exceeds another portion of the same supply chain, because no customer benefit will be derived from that.
Our focus is on improvement in production processes within the supply chain by partnerships or networks of companies. We're going to look at the experience of 3 networks that have implemented improvement programmes with the support of the Society of Motor Manufacturers and Traders Industry Forum. While we refer to the work of Industry Forum, our concern here is with the underlying methods which have been applied by these and other organisations, and with the effectiveness of these methods in improving company performance. We feature networks led by Mayflower Body Parts and Nastec Steering Columns, both based in Coventry, and Perkins Engines, based in Shrewsbury. All 3 companies are Tier 1 suppliers. This means that they act as the hub company for a supply chain learning network.
A Tier 1 supplier, as we move into this new century and new millennium, is rapidly being asked to perform the roles and services, many of the roles and services that the original equipment manufacturer was providing before, in that they must assume greater and greater responsibility for the individual child parts that go to make up their finished component, and with that responsibility for the components must go the responsibility for the performance and development of the suppliers that provide those components. So as we move towards larger and larger bought out vehicle systems and now vehicle modules, those systems and module suppliers, who are Tier 1 suppliers, must be able to properly manage the whole of their own supplier base, both from the point of view of component specification and manufacture, as well as the factor of continuous improvement and continuous cost reduction.
The 2nd and 3rd tier supplier companies referred to in the programme are spokes. We draw on the experience of TI Specialty Polymer Products, TISPP, and Sentinel, suppliers to Perkins Engines, as well as Steel and Alloy and Peterson Springs, who supply Mayflower Body Parts and Nastec Steering Columns, respectively.
In the supply chain group, the hub is the customer. The spokes are the suppliers to that hub, and we perform most of the training is performed at the hub company to show how the tools and techniques can be applied in a real-life environment. And we'd also conduct a workshop at the hub. We'd then go on and perform workshops at each of the suppliers. Ideally, the suppliers would recognise that some of those same tools and techniques, some of those benefits could then in turn be applied to their supply chain, and so the whole effect would cascade down.
Sentinel, I think, is probably one of the best examples that we've had so far, because they've taken the programme so many steps further. Not only have they focused on passing through the improvements through different areas within their business over and above what we'd focused on through the workshop, they've also taken it through to Stafford, our Stafford facility, and they've taken things up to a lot higher level, right the way through the supply chain. It's not just about us being able to support our suppliers to deliver improvements, it's about them being able to make the improvements even further within their organisation, continue to pass it down the supply chain, through their suppliers, as well as extending the benefits across their business.
It certainly convinced me that it's something that we can do to substantially improve our business, because we are a design-led business and our manufacturing is really the assembly of parts supplied by subcontract suppliers. So we're very much, in fact, the largest part of the cost of our business is in fact purchased parts. So suppliers are absolutely key to our business. And whilst we've done quite a lot in the last few years in terms of developing the business in terms of continuous improvement, lean manufacturing, a lot of those techniques we haven't been very good at getting down into our supply base, and so that's what we plan to do.
The QCD-focused approach has resulted in some substantial improvements, efficiencies and cost savings.
Looking back at some of the programmes that we've run with suppliers and some of the specific workshop activities, I must say that first of all, Nastec's primary purpose of running this was to upskill NASTech people to deliver programs and upskill suppliers. But there have been tangible results, some very remarkable results at that. We would look at, for example, helping suppliers reduce their changeover times on machines. I can remember a spectacular result where the average changeover time for a particular process was 69 minutes. Now, by applying the fundamental tools and techniques, we reduced that to 4 minutes. 69 minutes down to 4 minutes, which in turn gave us a lot more time when they could produce parts that would make money. Another particular success we can cite is where we helped a supplier improve his right first time quality by 88%.
It's also established a proven method within most of the suppliers that we've worked with to allow them to continue to make those improvements. And I think that's the most significant thing about the programme, is it's long term, it's continuous improvement, and it's giving suppliers and Perkins people the tools and techniques to go out and do that, and to make sure that these changes are long term and sustained.
We've seen practical changes. We've seen improvements in productivity. We've seen improvements in setting times. We've seen improvements in people profitability and productivity. So they are tangible. There's no doubt. Documented, well documented, and we need to make these changes to become a world-class business.
On the 500-ton press, when we did the workshop on there, our main concern of lost downtime was due to tool changeovers. So we did an activity on the tool changeovers, and we brought the changeover time down from 104 minutes down to 30 minutes. We've increased the people productivity by 14%.
There's a great impact for the suppliers in the bottom line when you look at these improvements. Obviously, if we're improving their right first time, so the first time they make it is the correct quality, it means they don't have to rework it, they don't have to use more hours of their valuable labour resources to make another one, and of course they're not consuming the raw materials required. And furthermore, of course, they could be using that time to make another part for another customer and make more money.
Achieving positive results like these depends on a number of factors. A carefully structured approach that introduces sets of tools and techniques and which helps people to learn and apply them. Systematic investigation which measures activity and includes the use of video as a tool. In-company teams that combine key shop floor members and members of the management team. Support from a number of key people with specific roles to play. Support and commitment from the most senior executives in a company. The structured approach emphasises scrutiny of the main manufacturing issues faced in each company in a supply chain network, starting with investigation that aims at diagnosing the most critical problems for QCD performance. Gerald Robinson is working with a team from Steel and Alloy, suppliers to hub company Mayflower.
I'm at a diagnostic at the minute with Steel and Alloy, which is really analysing information to identify improvement, activity, focus of what we need to do to actually make the biggest impact in this particular company. What we try and advise is that a company pick a particular area that's going to give the maximum benefit to themselves and also to the host company. Really then it's about using that particular area to bring about some improvements in there. So ideally that decision should be made supported by good logical data or data-driven approach, so that it is actually their biggest area for improvement in terms of whether it's a problem or it's the biggest cost centre, etc. Hence, that's the area that we go for.
We filmed the actual operator doing his daily work, as it were. From the videotape, we broke it down into a number of specific sections, highlighting the areas which we feel are important to his job role, breaking it down into automatic, manual, and from that we managed to establish that obviously the percentages of his job which was taken up were 22% was actually doing work, 67% was standing there pressing a button waiting for something to happen, and the reminder was walking.
To summarise then, basically what we have here is a potential in terms of the automatic time and the walking of roughly about 80% that could be taken out. It's not actually adding any value in that process. So that's something to concentrate on in terms of waste elimination, actually making an improvement in that particular process.
Measurement is a key element in the structured approach. Analysis and discussion of the results and repeat measurement is a continuous task and one that needs to be firmly embedded in company practice. Developing a strong, coherent team is absolutely critical, both for measurement and for continuing the improvement process in the long term. At Mayflower, the focus on teamwork within the company and the wider team across the supply chain learning network has helped to develop a more cooperative style of working.
It was asked individually, and we got together, sort of pulled up all our resources together and sort of got the best medium of each man on the section. You know, everybody doesn't work the same, we all work differently, you know. So got to sort of compromise, made a compromise, and that was it. I think it's worked pretty well. Worked pretty well, and plus the fact we produced a production without any stress or whatever, you know.
If the people within the area don't feel involved in the improvement process, they're going to feel very alienated and be quite possibly resistant to it. If people also don't understand why they're doing that, one of the core objectives is to cascade the knowledge and the know-how of improvement activity, and hence that's one of the other key roles of the change agent, that people understand not only that they should be doing something but also why they're doing that.
One of the vital tools for effective team functioning and investigation is the use of video. Video is used to capture how work is really carried out, its routines, where material has to wait for processing, movement of stock, and so on. At Perkins Engines, video has played an important part in helping the team balance the assembly line.
Well, how we approached it was video in each section of the line, and to start with, people were a little bit reluctant to have video taken of them, for obvious reasons really. Don't like being measured, but once it was all explained to them, and people gave an opportunity to have a look at the videos themselves, then people became more and more happy with the idea of video being taken.
So we filmed each stage of the process and broke those stages down into smaller times, and then rebalanced the line stage by stage to give a more equally balanced line ratio. Initially we went from building what we thought was a maximum build of 13 engines per day, and now that's risen to 15 engines per day.
Video can often help operators get an entirely different perspective on the work they carry out routinely.
If, for example, you're videoing a setup reduction exercise, it's very useful to get the person that's done that setup reduction exercise to review their video. And it's often a great surprise to them when they say, did I really do that during the activity? If I've just used a stopwatch to get that information, it's often my interpretation. It's often open to criticism or people to pass comment on as to whether I've pulled the numbers on that or not. Using the video, it's an open book technique. People can see what's actually happened, and we can run the time off the video to see how long the activity is taken.
Here's an example of a changeover reduction we videoed at a company recently, and here's a guy here who's done an excellent job in his setup. He's got time for a fag now, just wiping the sweat off his brow because such a good job he's done there. That's something very simple. Right, now where's my cutters for that band of steel? Not in the toolbox, not on the rack. Hey Fred, you got my cutters? Yeah, he has as well. Let's go take a walk round the back. There's old Fred. And where are they? Yes, old Fred's put them in his toolbox. This is one of the things that we try and bring out in the video analysis, and about 5C workplace organisation. There should be a place for everything in its place, and this guy could have picked up the correct tool straight away and finished the job off.
When the team has identified the areas for attention, the next step is to look at these in detail using a set of basic tools and techniques which are viewed as building blocks for continuous improvement.
There are 4 main building blocks, which are 5C activity, which is predominantly about workplace organisation, 7 wastes, which is showing people the difference between value-added work, non-value-added work and wasteful work, where there's opportunity to make improvements. Standardisation, where we look to try to identify and adopt the best method for doing things. And lastly, visual management, where we're trying to make it more obvious if something is in a normal or an abnormal condition. There is some overlap between some or all of those building blocks, particularly visual management and 5Cs. Some of the things you would do in a 5C activity, for example, the configuration of things, you're making it very visual, you're making it much more obvious if there is a problem or not.
Initially, we knew from, even before our diagnostics, we said that setup reduction time was the key thing that we wanted to look at. But the other things that we started to look at was scrap reduction, the amount of parts that dropped on the floor, the use of material, all those things we could measure very easily. Inventory turns, our stock turn improved dramatically. They're the clear things that you can measure and quite, and also you can share that measurement level with the employees very easily because they understand it very easily once the measurements are there.
We'll look at some of these in more detail. First, the 5 Cs. Clear out, configure, clean and check, conformity, and custom and practice.
The main improvement in conducting a 5C activity is a better organised workshop. It's a way of clearing out what you do need from what you don't need, deciding those things that you do still require, where you're going to put them, so you know always where to go, where to put your hand on those things, and that when you pick them up they're in a serviceable condition. You've not got to pick something up which is broken or leaking or whatever.
The clear-out phase of the 5C includes use of a red tagging process. Red tags are attached to identify problems in areas such as machine functioning and services layout, which may need to be put right. During a 5C activity, a log is produced of all the identified problem areas. A plan of action to address these problems is then drafted. The status of these actions is then monitored and updated until the problem is solved and the area back in full working order. All areas will then be monitored into the future.
From the 5C activity, this is one of the areas that we spotted. When we carried out the red tag exercise, we identified this area here as being a major problem, causing us severe loss in pressure on the hydraulic system, which is causing the machine to come to a standstill, losing production. We cured the problem after doing the 5C exercise, and now the production has gone up by about 1 tonne an hour.
One of the things we did was we actually performed a 5C activity on the setter's toolbox. We emptied out the contents of his toolbox onto the floor, and there were over 1,000 items in there, some of which had no purpose whatsoever being there because they were plumbing fittings or bits of string or just general things that really should have gone in the bin, or he should have taken them home with him. When we slimmed those 1,000 items down to those tools he needed for the job, we only had about a dozen tools, and we suggested that he would lay those out either in the top shelf of his toolbox, or better still, that we would start to construct a shadow board so that he would know where to put his tools, and if he hasn't got them to hand, why not?
It is infectious. I mean, it's amazing how infectious it can be. I had an example for it when we originally did it, that they decided to do it in one of the offices. I mean, they decided to do a 5C7 wastes, and we found that one girl had sufficient Bic biros to last for 105 years or something ridiculous. The idea of the 5Cs and the 7 wastes is not new. It's just reiterating absolutely sensible ways of working. It becomes infectious. If the enthusiasm is shared, it just flows through the rest of the plant. Of course, you have to also put a change agent there to make sure that we're measuring and continuing to measure so we can hold up the successes.
Equally as fundamental as the 5 C's are the 7 wastes. These are overproduction, excess inventory, unnecessary transportation, inefficient process, idle time, that is, ineffective use of machine and operator's time, unnecessary operator activity, and bad quality.
7 wastes are really a way of getting people to think about work which adds no value and is ultimately unnecessary as well. So typically, if you would ask people what's wasteful work, they may come up with scrap, because it's obviously something we spend a lot of time and money on and you throw in the bin. But it may not be quite so obvious to them some of the other areas of waste, such as idle time for the man or the machine, where the operator is waiting for a machine cycle to finish, for example. Excessive transportation, where parts are moving sometimes hundreds of metres around a shop floor. Process waste, where we've got an inappropriate or poorly designed process. Operator motion, where the operator is having to reach, stretch, bend too far, often linked with the ergonomics of the workplace. Not only does it increase the time taken to do the job, but it's also more likely to lead to injury or fatigue for the operator.
At TISPP, the 7 wastes analysis drove the rationalisation of component assembly procedures.
The way we used to assemble normal components is we lay a whole table out, and then we put the first component, which is the gasket, then the PTFE element, then the inner shell, and that's all done on a laid out table. Then they're stacked up, and then they're waiting for the next operation, which is spinning, which will be done by another person. Then they will be all spun in one cycle, moved onto another bench, and then they will be all loaded. So you've got sort of 3 broken operations. The way that we've laid them out now is you get one person assembling one seal, putting it onto the machine, where another person will spin it. And while that one's being spun, another one's being assembled. So when that's finished spinning, the other one is put onto the machine to be spun, and then it will be loaded, the one that comes out to be loaded. And then we're doing 3 operations in a one-piece flow. So, and a quick calculation, and it is a quick calculation, is saving of about 25% quicker.
But a 7 wastes analysis of how these assemblies were packaged for delivery to the customer also yielded significant savings.
We've had significant cost savings on packaging, cost savings on product, cost savings on delivery. In terms of the delivery itself even, the work that we did on packaging, prior to what you've seen today, we actually used to send those out to cottage industries for packaging. That would actually put an additional 2 days into our supply chain. That has now been removed, so it's not only given us a cost saving, it hasn't impaired quality, but in fact delivery, we're now able to respond to the customer 2 days quicker than we could previously.
With the packaging, we used to individually pack into plastic bags with a fitting instruction, and this piece of cardboard, well, this piece of cardboard is 6 pence each, believe it or not, and 20 of these go into one box. We can eliminate this bit of cardboard because all they were doing was throwing it away at the other end. So we changed the packaging spec to get rid of the plastic bag and the fitting label and just wrap them up into protective wrapping. And we've succeeded in doing a few parts like that, which has saved money and time.
Central to the concept of waste is that work activities are classified into 3 types. Those which add value to the material or component you are processing, those which do not add value but which may be essential to support the value-adding process, and those which are unnecessary or which otherwise contribute to waste. The most effective diagnostic approach involves combining use of both the 7 wastes tools and the 5 Cs, selecting those tools which are most applicable. At Sentinel, a combined approach was taken to exploring one particular aspect of production, coolant galleries, which are fitted to Perkins engines and which represent approximately 10% of Sentinel's turnover.
This is a typical coolant gallery. It's a casting with several machining operations on there. Depending on the application, there's either 2 or 4 of these fitted to the engine at Perkins. We videoed a typical changeover on the shop floor. When we broke the changeover time down at the start of the activity, we could see that the majority of the time, almost a half, was going on replacing tools and fixtures. Next up, producing the first off. Next up, deburring inspection. Finally, changing tapes and offsets. Having seen where the time was going, it was clear that the area to look at first was what we could do to either reduce or eliminate the changing of the fixture and the tooling in the carousel. And that's the area that we focused in as first pass on the workshop.
The old workplate can only accommodate one size of gallery, so it had to be changed over if larger galleries were to be worked. This took time.
We performed a 5C activity on the machine and looked to see where we had wasteful activity in the changeover process, and we identified that we could do something to commonise the fixtures. So rather than having to take fixtures on and off the bed, once we reviewed the engineering content of the fixture, we could modify one to do all variants, which means that we save time on both the loading and unloading of that fixture to the bed, and also the datuming of that fixture from the quality point of view. Similarly, with the cutting tools, the previous practice was to take out all the cutting tools and replace them with the tools required for the next variant. When we sketched up a matrix for what tools are required for what variants, we found that there were enough positions on the tool carousel to permanently locate all tools on the machine. It meant some rewriting of the program, but that was done on site. And again, we were then able to eliminate that need for changing the tools completely.
And these changes have had a profound effect right through the company.
Jobs have been linked together now that are similar, and they'll run together, and it saves us a lot more tooling changes. That most of the tools are in the machine all the time now, whereas we were taking a tool out to do the next job, and then the job come along, the next job you had to put that tool that you just took out. Yeah. But a lot of that comes from minimum and maximum stocks, because we can keep an eye on it and we can do the jobs that use similar tooling all at once.
It used to be very boring before, but now you're involved in everything really. You know, we get a printout on the board of what rejects have been for the month, and those are very low, so we're obviously doing all right. So yes, it's being involved. You've got to be informed of what's going on. It's no good being stuck in the corner and sticking your head in the sand. You want to know what's going on.
So at the end of the workshop, we were able to restudy that changeover, and we went from 46.5 minutes down to 16 minutes. The replacement of the tools and fixtures was totally eliminated, so that time went to 0. We made some improvement on the production of the first off, because we weren't having to step the program through to check all the datums, because they'd been preset by leaving the parts in their original position. So we got a before and after situation here. So we reduced changeover time by about 2/3 at a cost of almost 0. Some minor modifications to the fixture that were done in-house, and some rewriting of the computer programs. Because the products we're looking at on this site are relatively low volume, some of the finer techniques of line balancing, etc., certainly weren't applicable. The main techniques we used to drive forward the program at Sentinel were the application of 5Cs, 7 wastes, and setup reduction.
These activities can lead to some more fundamental reorganisation in the target production areas. For example, in developing cell manufacture in the Nose construction shop at Mayflower. John Hochian played a central role in this reorganisation.
What you're currently looking at the moment is the improvements that's been made on the cell. These have been made through various initiatives, i.e. behind us is where we originally had the den cell area. we've decided to move the den cell and locate it within a dedicated area. And also, we've moved some of the plant and machinery, the portal welders and the spot welders, into this area to make it a dedicated cell. Productivity has increased, efficiency has increased, and we've reduced the amount of downtime we had in the area, i.e. people walking, and also big stillages that we see lying around which taking up valuable space and now being utilised. The area is being utilised effectively. What we've done is, whereas before the operation was performed on the den machine over here, the item was then transported by fork truck over to the area for assembly and to final metal finishing has been eliminated. With it being a dedicated cell, we've eliminated the need for big stillages and introduced mobile racks. On the mobile racks has allowed the operator on the den machine to take a component from the press shop, trim the item, flange it over and offer it to his partner right next to him to assemble. So again, reducing the amount of movement has increased the productivity in the area. Mayflower's production rate on a standard nose is roughly around about 76 components per day. This has now risen to in excess of 110 components per day, purely by minimising the amount of walking and actually delivering the components on mobiles rather than having to stand there and waiting for a forklift driver to come and deliver the items to you. Some of the benefits that we've got from there is obviously, as we've explained, cost savings in both efficiency and productivity. Also, we've got a flexible cell now. It's far easier to rotate the people within the area. So should we suffer from any form of absenteeism or any form of downtime, there is always work available within that area. One of the key things I think as well is about obvious waste and adding value to the business. Whereas before, if we had 2,000 noses around us, we'd just go ahead and build them. The customer would only want a proportion of them. The Energy Forum has educated us in the fact that if the customer wants 478 this week, then you build 478. That's how the cell operates now. And eventually, once a production run is finished and we complete the cycle for the customer, it enables me to free people off from the cell and move into other areas.
Another example of sophisticated development is a shift to Kanban organisation at Perkins. Kanban is a system that provides both improved control of production processes and a means for continuous improvement. It aims to reduce levels of materials, parts and so on to the most efficient levels throughout the supply chain. This involves producing and supplying parts only when they are needed, at each step of the production. Parts are never produced for stock, but only when customers use or indicate a need for that part.
The Kanban itself has been a very, very new initiative to Perkins. It's been something that's talked about a lot, but I don't think people really understood what it meant. And for us, it meant putting suppliers on a system which pulled material through to meet customer requirement at the end of the day. So the way the Kanban works is there is a strategic number of Kanbans in the system, whether that's containers or cards, basically a strategic number to support what the customer wants being the line. The advantage is stability, it's standardisation, it's knowing that what we want is there when we want it, and having the visibility through good packaging solutions and handling systems to know that we can walk to that bin and there's one bin there and that has got today's quantity in it, and that we can pull that through and then either the bin works as a trigger or a card works as a trigger, and we know that the supplier is capable of delivering that. From an inventory point of view, it's reduced the amount of inventory. It's also stabilised the amount of material we've got. We know exactly how much material we have got through the system, and we have the ability to flex that up and down, but also understanding how much the supplier can meet those flexes and changes.
Line balancing and standardisation of processes set down the most efficient way to do a job and ensure that standard methods of safety, quality and productivity are maintained. Line balancing is concerned with the linked production stages in a production area. It aims to remove bottlenecks that cause delays in order to achieve balanced flows and loads between operations. First, this involves identifying the critical bottleneck operations by calculating the takt time, the rate at which customers demand a particular part or component. This is calculated by establishing the total available production time in the production cell and dividing this by the quantity needed by the customer. Each operation is then related to the takt time. Those operations above the takt time represent a risk or potential bottleneck. Those below the line represent an opportunity to absorb more work. The aim is to balance the line. Reorganisation involves looking at bottleneck operations and at how they can be reduced. This can include redesign of work layout and the reorganisation of work methods. Standardisation involves establishing these new methods as standard or normal practice. Gradually, each operation in a cell is likely to be analysed and new standards established.
The build line is a stage-by-stage build process, and each stage is balanced to a takt time. What we identified through initial research was that some of the stages weren't as well balanced to others as what we originally thought.
We knew that certain stages were quicker than others, so within the takt time that we had and the target takt time that we were going to work to, some stages had less work on the stage than others, and there was certainly some fine-tuning to be done. There were also stages that were seen as problematical where we were struggling to get engines through within the time, so there was obviously a balance problem there, and we immediately went and focused on that.
Visual control ensures that the workplace is effectively maintained with clearly identified locations for components, equipment, movable tools and so on. Managing the workplace is much easier if information is available at a glance. If a problem develops, it can be solved rather than going unnoticed. In this factory, different colour coding on the floor identifies where equipment is stored. Visual control helps identification of problems in production organisation, for example, where part flows are becoming unbalanced. If the quantity of parts at a workstation starts to exceed the target level, this is immediately visible because the parts start to spill out of the designated area. Tools can be much more readily found if they are kept in clearly designated areas. The common approach building blocks we've described so far are methods which enable companies to identify areas which will give the greatest improvements to a process from raw material to finished goods. Focusing on this value stream raises some important issues. Value-added activity cannot be treated in isolation. There is always room for improving the efficiency of value-added activities. Non-value-adding activities also need careful scrutiny to ensure they really are essential and that they are as effectively organised as possible. And product focus. Are there ways of extending a company's product range, perhaps outside the automotive industry, by using metal shaping skills to make products for different markets? Or are there ways of increasing the level of value added to a component?
We have to find ways to diversify. We have to find ways to take that spring and add value to it. One of the ways we can do that by taking what we do and improving it until we are as good as the world standards, so that we can make the spring to the highest possible quality at the fastest possible speed. But even that's not going to save us long term. Eventually, I imagine that many of the very simple, straightforward springs we make will be made where there's an even lower labour cost. We will be left with the intellectual requirements to design the parts, develop the parts, think about how to pack them so they're good for automatic assembly, that type of thing. And that's certainly where we're finding we're getting a benefit. Again, only possible if you are actually at the cutting edge of cost and quality.
Tools and techniques such as the 5 C's, 7 wastes, standardisation, visual control and videoing are essential to achieve continuous improvement. Another critical factor is the commitment and support of key people within an organisation. The programme involves 3 key roles: an expert engineer skilled in improvement methods, the supplier development manager in the hub company who acts as leader for the whole project, and the change agent who leads the improvement process within the individual companies.
The role of the industry form engineer on the supply chain groups is to act as facilitator. So it's to train the various people from the suppliers and Perkins in the tools, techniques of process improvement, and then also to facilitate the workshops where we see how the tools and techniques can be applied in a real life situation.
Skills the IF engineer really needs are good people skills, good presentation skills, because we're working with teams of people, guiding them so that they can carry on with improvement work, and more importantly perhaps a desire to actually ensure that manufacturing in the UK succeeds and remains to be competitive on a world basis.
Each hub company nominates a senior manager to take overall responsibility for the network. They are called supplier development managers.
There'll be a project leader for the hub who coordinates the programme, will be involved in the selection of the suppliers and will really monitor the performance of the whole programme as it goes on. That person would also attend the training and the workshops.
One thing we have been trying to develop with our suppliers is a partnership. Now, we recognise that trust and honesty are things that you have to work at. Now, the degree of dependency that Nasdaq has on the supply base means that we have to build a partnership with each supplier so we can get them to trust us, and in turn we have to trust them. Now, that trust has to be earned, it's not just there.
We are prepared to support our suppliers, that we identify a group of suppliers that either form a chain through regional criteria to meet the Accelerate programme, or they are a group of suppliers that might be strategic to Perkins, that can learn from each other. So normally we would try to select a supply chain group that was different in terms of being different types of products. So we might have a selection of small and medium-sized companies, but then we'd have 1 or 2 larger organisations so that they could learn some of the different problems that those companies might have, and then they can go back and apply them in their own organisation.
Each supplier company selects a change agent, a member of staff who takes responsibility for implementing activities and liaising between factory staff and management.
A good change agent is able to challenge things. He's enthusiastic about the improvement process. He's quite well driven and not satisfied with the status quo, in effect. We're looking to take it forward, to challenge where the next process improvement is coming from, and that, you know, just to be the same is not good enough, in effect.
The role I undertake as the change agent in this instance was really to be the catalyst, to be the contact between us at Doughty Engineered Seals and the customer. I had a concern prior to going in. I thought age may be a barrier. No, age isn't a barrier. Providing you are open and prepared to accept new ideas and to listen and to apply them. If at the end of the day it doesn't work for you, and that's the emphasis. At no time were we told that this is the way to run your business. We were always encouraged to develop our own ideas, because nobody knows your own business basically better than you do.
In general, I think most change agents go back to their own companies with a great deal of enthusiasm. Now, I think process improvement for a lot of companies are very much a roller coaster ride, and it can have very good times and very bad times. Their enthusiasm really needs to carry them over all of these sorts of periods, and when things are at a low ebb, they really need to be able to pick themselves up and drive it forward some more.
A total package of building blocks, tools and techniques, how they link together and how to apply them and improve work methods presents a complex challenge. To develop an integrated perspective, the change agents work on a comprehensive project, building clocks.
You can use the same concepts. Yeah, it doesn't mean that you have to go to one-piece flow. In this change agent training, essentially what we have is a scaled-down version of a factory which manufactures clock units. The change agents have the opportunity to learn process improvement tools and techniques and apply them to this clock manufacturing process. and find ways of using them to improve that process. It's a learn by doing activity in a safe environment before they go back to their own workplaces. There are a number of operating stations which either mark out, machine or assemble components together, and then they're finally inspected and packed. The clocks that are made consist of a top plate and a bottom plate, 4 pillars and a centre which rotates. Well, the clocks may appear very simple to make, however, they've been cunningly devised to be quite difficult to make. It's very important that you drill the holes in the plates in exactly the right position and relative to each other, such that the clock will freely rotate between the pillars without catching. Also, the length of these pins must be made very accurately in order that the clock doesn't wobble or fall out altogether. They can challenge the work sequence, they can remove unnecessary operations, and they can make their own jigs and fixtures that make the job easier. These sorts of principles they can take back with them to their own factories and apply them to their own manufacturing processes. Throughout the week we keep a scoreboard, and that will document how they've improved step by step through the week, and that would measure productivity, quality, work in progress, profitability. Okay, well, we have a fixed scoring criteria, which is the same for every trial. And by entering the scores after each trial, we can see how they're progressing. Okay, so we have number of good clocks made, number of bad clocks made, work in progress at the end of the trial, parts per operator hour over the trial period, throughput time. That's the time it takes for the first batch of clocks that the team have made themselves to get from one end of the line to the other. How many of the clocks they would manage to sell at £40 each, how much raw material they've used, both in good clocks, bad clocks and work in progress, how much profit or loss they will have made while they ran their trial, what the total work content was, okay, so the sum of the cycle time of all the operations, and a 5C score. How did you rate their workplace organisation? Typically, the first time they make clocks for an hour, they don't make any good ones at all. And as we go through the week, they will progress towards making 30 clocks in an hour and more, good and right the first time.
Right, telling you to stop it. Is it?
What's happening now is the team are analysing video that we took yesterday while they were making clocks. They will use the video to break each operation down into steps or elements and analyse each of those elements to look for improvements. Improvements would be things such as making awkward operations easier, eliminating transportation of parts around the factory, and reducing the amount of operator motion required. So having analysed the videos, the team have made further improvements. They've changed the layout of the factory and they've balanced the line so that each operator has an equal amount of work to do. They're now documenting their operating procedures.
Having looked at the video this morning, we went through the operations that I was doing and timed them. And the time that was recorded was about 145 seconds. And that was 55 seconds lower than the actual takt time. So as a team, we've gone through a line balancing exercise, and it was decided by the team that I'd take on the gluing operation, which is about 33 seconds, and that's just added onto my process time now. So I'm closer to the actual takt time instead of having idle time. So I've taken on another operation. Well, basically, after watching the video, we've calculated my process time at 206 seconds with a takt time of 200 seconds, so I wasn't looking to cut my operation down by much. The thing that we found, I was spending 10 seconds
moving my jobs from one end of the room to the other. So just by cutting them 10 seconds out, I've got within the 200 seconds tack time.
Today's been a trial day where the teams are putting into practice the things they've learned. So most of my role today has been assisting them in making sure they've got the bits and pieces they need around them for good 5C condition, and also testing them, asking them questions all the time so that they're thinking about what they're doing and putting in the best possible solutions. In addition to that, we have to monitor what they do during the trial period. We video, we take times so that they can see against their benchmark of the first run just how successful their improvement work has been.
I think that people start off by thinking, well, all of this is common sense. Surely it can't be this simple. But by the end of the week, after showing them again and again and again that although it is common sense, it's about rigorous application and discipline that makes things work, then that changes their minds for them. They really understand that although they might be attempting these things in their own workplace, they really need to be stricter about them. The law of diminishing return applies here as much as it does anywhere else. Great deals of success can be had early on, but as you go on, it takes more and more effort to get less and less return, unfortunately. But that's real. When they go back to their own companies, they'll be able to make great big strides to start with, but it'll get tougher and tougher to make progress.
The final but vital component of a successful continuous improvement programme is the commitment of senior management from the very top of an organisation. Without that commitment, the impact will also be felt along the entire supply chain, impacting on other participating companies.
Through around 15 years of experience at Land Rover of customer-driven supply development, we have now learnt that probably the single biggest factor affecting the success of any improvement initiative is the involvement and commitment of the supplier chief executive. We now recognise that if that chief executive does not believe that the representative from the manufacturer can really help his business, if the chief executive is not actually involved in the generation of the improvement plan for their company, and perhaps even more importantly, committed to personally driving the successful implementation of that plan, the chances of success are slim indeed.
But at the end of the day, if the individual managing director, chief executive, does not see the need to change, does not wish to lead that change, and above all, does not wish to get himself educated and trained to understand he needs it and understand how to tackle it and communicate that, then really you're wasting your time. You may as well get rid of him quickly, and he's just as expendable as a maintenance engineer down the line who's desperate trying to block the change because he doesn't think it's going to work. You don't distinguish. He's got to be moved out.
As purchasing manager at Mayflower, Peter Lawson's involvement in the programme demonstrates the importance of commitment from all areas within a business and the need to demonstrate real, measurable benefits.
Inevitably, it requires a certain amount of discipline by the companies themselves to push themselves ahead and keep ploughing on with the programme internally while they are obviously busy making products and trying to manage their own businesses. And Mayflower's found itself that it has to push itself through that barrier and try and instill the toolkit approach as part of its normal way of business, and also ensure that the continuous improvement that should be generated out of those workshops is being measured at the highest level, and that is a board level key performance indicator that makes the difference between those who are successful and those who aren't.
The approach we've outlined in this video is not a one-off exercise, but a continuous process of analysis, measurement and reporting which has to become deeply embedded within a company's standard practice and culture.
Continuous improvement is actually the end game. Now, when I say it's the end game, it's a game which never finishes, of course.
Those companies who've got that message have got no problem sustaining it. It's not a question of resource. It's really a matter of horses for courses. Mayflower may be running six programs right now. It would delight me if all our first phase of suppliers were sustaining successfully and showing continuous improvement in just one program with the originally trained change agent.
We want to help our suppliers enhance their margins as well as we can enhance ours, retain and indeed win more business, particularly in the automotive sector, which is currently the most competitive, for the benefit of all of us. That has to be our objective.
We have to continue to become more productive. What we've found is that we've understood now into a much deeper way the reality of what quality improvement means, what process improvement means, and that's been done on the shop floor with shop floor people. That's really, really made the difference. It becomes infectious. If the enthusiasm is shared, it just flows through the rest of the plant.